Algebraic expressions. In this module, you will learn about algebraic expressions, terms related to algebraic expression, addition and subtraction of polynomials, multiplication of polynomials, and special product. A term is a number, a variable or a combination of numbers and variables. For example, 2, 5y, 3x squared by 7. Here the sign of multiplication and division do not separate terms. Like in above example, 3x squared by 7 is a single term. A single term or a combination of two or more terms connected by additive, both addition and subtraction, and multiplicative, both multiplication and division, symbols, forms an algebraic expression. Example: 5x squared plus 2x minus 5 is a combination of terms. We notice here the terms are connected by additive symbols like addition and subtraction. Then 9x divided by 5 and 4x squared multiplied by 5y. Here we see terms are connected by multiplicative symbols like multiplication and division. These expressions formed are called as algebraic expressions. Let us see now types of algebraic expression. An algebraic expression which contains only one term is called monomial. For example, 6, 11 by 10, 7x, etc. An algebraic expression which contains two terms is called a binomial. For example, 3 plus x, pq minus 3, etc. An algebraic expression which contains three terms is called a trinomial. For example, 2 plus 3 plus 4 and ax plus by plus c, etc. An algebraic expression in which each term contains only the variables with non-negative integral exponent is called a polynomial. For example, x squared plus 5x plus 3. Let us consider a term 4y. Here 4 is the numerical coefficient and y is called as variable. There are basically two types of terms, like terms and unlike terms. Like terms. Terms having the same variable with same exponents are called like terms. Example: 2x and 3x are also like terms, and x squared and 3x squared are like terms. Unlike terms. Terms having the same variables with different exponents or different variables with same or different exponents are called unlike terms. Example: y and y squared are unlike terms. Also, a, b, c and d are unlike terms. Let us see some factors relating to variables. First, if the variable has no sign, it is taken as positive. Example: variable y is considered as positive y. Second, if the variable has no power, it is taken as 1. Example: variable z is considered as z raised to 1. Third, if the variable has no numerical coefficient, it is taken as 1. Example: variable a is considered as 1a. 4. The highest power of the variable in a polynomial with the single variable is called the degree of the polynomial. For example, 5x squared plus 9x plus 7. So here, the highest power of variable x is 2. So the degree of polynomial is 2. Let us take a look on the properties of addition in the set of all integers. First, sum of two positive integers is a positive integer. For example, plus 7 plus 5 is equals to plus 12. Second, sum of two negative integers is a negative integer. For example, minus 7 plus minus 5 is equals to minus 12. Third is, sum of a positive integer and a negative integer is positive if the absolute value of the negative integer is smaller than the positive integer. For example, plus 7 plus minus 2 is equals to plus 5. Fourth, sum of positive integer and a negative integer is negative if the absolute value of the negative integer is larger than the positive integer. For example, minus 5 plus 2 is equal to minus 3. Now, rules for addition and subtraction of two polynomials. First, like terms can be added or subtracted. Second, unlike terms cannot be added or subtracted. Third, while adding or subtracting like terms, their numerical coefficients are added or subtracted. Let us solve some examples to understand it. Add and subtract 2a square b minus 5a square b and 8a square b. Let us first do their addition. So 2a square b plus minus 5a square b plus 8a square b. As they are like terms, we can add them all. Taking a square b common, we get a square b into 2 plus minus 5 plus 8. That is adding the numerical coefficient. Therefore, we get 5a square b. Now we will perform this subtraction. 2a square b minus 5a square b minus 8a square b will be after taking a square b common, we get a square b into 2 minus of minus 5 minus 8. Therefore, we get minus a square b. This is the horizontal way of addition and subtraction of polynomials. We can also add and subtract by vertical way in addition. Writing all terms as vertically and adding them, we get again 5a square b. Similarly, for subtraction, writing all terms as vertically and subtracting them, we get again minus a square b. Similarly, we can add and subtract all like terms of given polynomials. Before learning multiplication of polynomials, let's learn some terms like coefficient of the product, which means the product of the coefficients of expressions. Algebraic factor of the product, which means the product of all the algebraic factors. Next is law of indices. When we multiply similar variables and we need to use the law of indices for simplifying the expression, which is x to the power m into x to the power n, can be written as x to the power m plus n, applicable for all integer values of m and n. Now let us see how to multiply a monomial by a monomial. Multiply monomials 3a square b and 4ab square. Solution. For multiplying first, we need to separate constants and variables. And also in variables we separate all unlike terms. So the multiplication will be 3 into 4 multiplied by a square into a multiplied by b into b square. Now by applying law of indices, we get answer as 12a cube b cube. Next is multiplying monomial by a binomial. Multiply 5a and 7b plus 3. Solution. By applying distributive property of multiplication, we get 5a into 7b plus 3 equals 5a into 7b plus 5a into 3. Now by distinguishing and multiplying, we get answer as 35ab plus 15a. Next, multiplying a binomial by a binomial. Find the product of two binomials, 3x plus 4y and 7x plus 2y. Solution. By applying distributive property of multiplication, we get 3x plus 4y into 7x plus 2y can be written as 3x multiplied by 7x plus 2y plus 4y multiplied by 7x plus 2y. Again by applying distributive property of multiplication and then by opening brackets, we get 3x into 7y plus 3x into 2y plus 4y into 7x plus 4y into 2y. Now calculating as multiplication of monomials and then by addition of polynomials, we get answer as 21x square plus 34xy plus 8y square. We can use all the properties of number to the algebraic variables like associative, commutative, and distributive, laws of indices, etc. As when we substitute numbers for these variables, all these properties are true. Now we'll study a special product that is a product of two binomials. Consider a product p plus q into p plus r can be written as p into p plus r plus q into p plus r. In this product, if we solve, then we will get the answer as p square plus p into r plus q plus qr. Now what if we change p by a? You will get an identity. A plus q into a plus r equals to a square plus a into r plus q plus qr. An identity is an equality which is true for every value of the variable in it. For example, a plus 3 into a plus 2 is equals to a square plus 5a plus 6 is an identity. If you give any value for the variable a, you will see that the left side and right side coincide. Let us solve a special identity, which is also known as standard identities, p plus q square. When we solve, we can write it as p plus q into p plus q. Now by applying distributive property of multiplication, we get p into p plus q plus q into p plus q. When we solve this, we get p square plus pq plus qp plus q square. Now by adding polynomials, we get p square plus q square plus twice pq. Thus we get standard identity p plus q whole square equals to p square plus q square plus twice pq. We can also understand this identity by geometrical squares. Observe that the square PQRS has area equal to p plus q whole square, since its side length is p plus q. Now if we divide the square in two smaller squares and two rectangles, area of square TUVS is p square and the area of square XQWU is q square. Now the area of rectangle UWRV is PQ and the area of rectangle PXUT is PQ. Thus adding all that, the area of square PQRS will be P square plus Q square plus PQ plus PQ, or we can say p square plus q square plus twice pq. Similarly, we can obtain another standard identity. P minus q whole square is equals to p square plus q square minus 2pq. Let us solve some examples on all the topics we learned now. Example 1. Separate the constants, variables, monomial, binomial, and trinomial in the given algebraic expressions. Solution. First, given algebraic term is 7abc. In the first part, we can see there is only one single term, 7abc. So, number of terms is 1. Therefore, 7abc is a monomial. Also, there is only a single constant, which is 7, and 3 variables named as a, b, and c. Second, given algebraic term is 9 minus 4b. In the second part, we can see there are 2 terms, 9 and 4b. Therefore, 9 minus 4b is a binomial. Also, 2 constants are 9 and 4, and a single variable named as b. Third, given algebraic term is 4 plus 5b minus 6c. In the third part, we can see there are 3 terms, 4, 5b, and 6c. Therefore, 4 plus 5b minus 6c is a trinomial. Also, there are 3 constants are 4, 5, and 6, and 2 variables named as b and c. Example 2. Add the given algebraic expression 5x plus b, 6x minus 2b, and 8x plus 3b. Solution. We can solve the algebraic addition by 2 methods. Method 1. Horizontal method. Separate the likely terms in all 3 given algebraic expressions. We get 5x plus 6x plus 8x plus b minus 2b plus 3b. When we add the likely terms, we get 19x plus 2b, which is addition of the given 3 algebraic terms. Method 2 is vertical addition. In this method, firstly, we arrange all the algebraic expression in vertically as traditional addition method by keeping likely terms in the same line. Now simply add the constants with respect to variables, and finally we get our result as 19x plus 2b. Example 3. Multiply the algebraic terms 2a square b minus ab and 3ab minus 5. Solution. 2a square b minus ab into 3ab minus 5 can be written as 2a square b into 3ab minus 5 minus ab into 3ab minus 5. By applying distributive property of multiplication, we get 2a square b into 3ab minus 2 a square b into 5 minus ab into 3ab plus ab into 5. Now by applying law of indices, we get our result as 6a cube b square minus 10a square b minus 3a square b square plus 5ab. Example 4. Evaluate algebraic expression using identity a minus b whole square is equals to a square minus 2ab plus b square. First is a minus 6 whole square. Second is 47 square. Solution. Let's solve the first part. By using the identity, we can solve this. Only we have to substitute 6 instead of b. We get a square minus 2 into a into 6 plus 6 square. That will be a square minus 12a plus 36. Second is 47 square. We can also write it as 50 minus 3. So by using the identity, we can write it as 50 square minus 2 into 50 into 3 plus 3 square. After calculations, we get 2209. Let us revise all that we have learnt in this module, algebraic expressions.